Imagine that you want a free trip from your house to any place of your choice. Your trip must be completed via hot air balloon ride. Assuming that your balloon is a perfect sphere, you know that the volume of your balloon is equal to 4/3 pi r cubed. Knowing that your balloon fills up at a rate of 150 cubic meters per second, and that it takes off when the radius is equal to 10 meters, you want to find out at what rate the radius is changing. To do this, you take the derivative of the volume equation. So you get dv dt equals 4 pi r squared times dr dt. Now when you plug in 150 for dv dt and 10 for the radius, you then get dr dt as your only variable, and when you solve for dr dt, you get that the radius is expanding at 0.119366 meters per second. Once you reach your destination, your balloon begins to deflate at a rate of 70 meters cubed per second, and your balloon begins to descend when the radius equals 8 meters. So now you want to know the rate at which the radius is changing as you descend. So again, we're going to use the same derivative of the volume equation. Now we're going to plug our new values in. So 70, which would be a negative 70 because the balloon is deflating and you're descending, equals 4 pi 8 squared times dr dt. And once again, when you simplify, you'll get dr dt on its own, and it equals negative 0.087038 meters per second.
As the volume of the balloon changes, the radius of the balloon will constantly change as well. To simulate this, we blow up the balloon via a straw attached to the bottom, and then we cap off the straw so the air won't leave the balloon before we want it to. And then to demonstrate the hot air balloon itself flying, we have it attached to strings on dowels, and we'll pull the strings down so the balloon flies up. And then when we're ready to have the balloon descend, we just pull the balloon back down to the ground and uncap the straw so the balloon itself deflates, like a real hot air balloon would do.